Okay, before I install the bipolar prom adapter into the programmer, I wanted to show you uh, what the jumper, how we do these configuration jumpers. I mean, you can, since it's a machined tool socket on the adapter, you can literally put, you know, 22 or 24 gauge wires around the different pins to configure it. Or if you want to support multiple bipolar proms, we use some 3/10 inch 24 pin dip sockets like this, and we just put the solder some jumpers across. This is one for the upper 12 upper 12 positions on the machine's socket strip, and this is for the lower 12 positions, and they just plug in. Okay, so, and it's, matter of fact, although we didn't do it on this one, we put a little sticker on there that says what the part is configured for. So you can you don't have to go through the process of wiring the individual points. You can wire insertable dip sockets, and they go right into the machined sockets on the adapter, and that makes it a little more convenient if you were dealing with different bipolar proms. If you're just dealing with one, and a lot of people just deal with one kind of bipolar prom, sometimes two, sometimes more, but it's not that common to have a whole bunch of different bipolar proms. Anyway, let's go ahead and I'll show you how we install this in the programmer. Okay, before I put it in the programmer, I've inserted a configuration, a couple of configuration blocks into the adapter here. This is for this 82S129, 74S287, and you can see that this does not go directly across. There's the wires are positioned properly to direct the drive electronics on the left into the appropriate socket pins on the right. But anyway, it just plugs into the socket strips on the adapter. Okay, now I'm going to install this in the programmer. I need to turn the programmer or get the programmer ready to go first, because of the way that this adapter works, there's a different procedure. Although you probably won't damage anything, we recommend that you be more careful with this adapter, simply because there is a 35 volt source that's applied to it, and with that voltage and the way the electronics works, sometimes it'll make a little spark if you connect the 35 volt umbilical, which is the yellow wire, and the orange wire is the 5 volt source. So we recommend that you power up the programmer first without the adapter, so that the computer can ID it, because we need an empty socket on the programmer in order to properly ID it. Then once it's ID'd and you enter the device type with which you're working, okay, then you would unplug the programmer, install your adapter, and plug the programmer back in. All right, and that's what I'm going to do. But first I'm going to get the programmer attached, and we're going to power it up. Okay, here we have the programmer with power on without the adapter installed. And let me switch over to the host machine here, and I'm going to double click the Prom Plus icon and get this started. Okay. The first device that I'm going to work with is the 82S129, and it's a 256 byte by 4. Okay. So its inputs, I need to figure this out. Let's see, 256. Well, 256 is I don't need to figure that out. That's FF. So it's 256 by 4. So let me enter the device type. We'll use the 82, wrong keyboard, 82S129. Okay, and I'm going to enter it. As you see, I'm entering it down here, right here. And I could go down to, matter of fact, I'll just show you. Let's just do that. I'm going to go ahead and I'm going to press enter, and it'll select the part. Anyway, this is how the dip switch on the programmer needs to be set, and then over here it says requires bipolar prom adapter part number ABIP. Okay, so that's the adapter that you would need. All right, but anyway, I'll clear the information this way. I'm going to use Command 9, and we'll just page down until we get to the bipolar prom category of devices, and that's right here. And here are all of the bipolar proms. Okay, the 74S and the 82S. That's the families that we support. There are no other manufacturers of bipolar proms that we, the programming algorithm. Reading, you can read any of the manufacturers, but programming you cannot. Okay, so you're going to have a 74S part manufactured by National, or you're going to have an 82S part manufactured by Philips Signetics. All right, let's get back to the main command list. And we always show you how to set the switches, and we show you tell you which adapter that you need, and your part number is always displayed up here, the part that you're working with. Okay, now here is the programming unit powered on, and here is the bipolar prom adapter. Okay, now in the case of most of our adapters, you can install them with the power on. There's not a problem. Okay, and in this case, I could probably get away with it with this as well, but I am going to show you the recommended way to do it just to be safe. Okay, so the programmer is now turned on, software started, meaning that we identified the connection to the computer, and we're ready to go. So what I'm going to do, you'll see that the AC power light is on here. I'm going to reach over to my outlet, pull out the power pack. All right. The programmer is now unpowered. So I am going to connect the adapter now, and I'm going to connect the yellow wire to the plus 35 pin on the accessory connector, and it's just got a slide over connector. So we'll slide that over, and the orange wire to the plus 5. Okay, this is how the adapter receives its power. Okay, so you can see that these just push over the top like that, push over the top of the accessory connector pins. Do not get them reversed. If you get them reversed, you will damage your adapter. It won't hurt the programmer, but the adapter will be seriously damaged. Now, this is a 28 pin adapter, meaning that the base is 28 pins. It's not 32 pins like the socket. So you need to insert it fully left justified in the socket. All right. Also, we have this little foot here, which keeps the adapter from rocking once it's installed in the socket. So I'm going to lift up the handle at about 45 degrees. I'm going to position the pins. I'm going to push the adapter down into the ZIF socket. I'm going to release the handle, and now we're locked in place. Okay. So the adapter is now installed in the programming unit. So I'm going to repower the programmer, plug it back in. You can see that the AC power light is now on. So we are now ready to begin work with our bipolar prom. Okay, I'm going to zoom in here just a tad so you can get a little bit better view of what I'm going to be doing. Okay, now this is where things become different than working with regular EPROMs. All right, as I said previously, bipolar proms, they program by blowing individual fuses in the part. And the way that that we treat these parts, there are two ways. Okay, most of the time, human beings are used to looking at information, hexadecimal information, and as just individual bytes on a screen. Okay, and we do the same thing, but in order to do that, let's go to the buffer editor, which is Command 5. Okay, here we are in the buffer editor, and if you look at the uninitialized buffer, you'll see that it's a screen of Fs. All right, that's just how we initialize the buffer for any device prior to you working with it. But if I read a bipolar prom with the adapter will always present the information in what we call bit mode. Okay, or if you want to think about it as fuse mode, where each one of these locations is a byte. But when we go into bit mode, each one of these locations is going to be a fuse. Okay, and as I said in the past, a fuse is an individual bit in the bipolar prom. Okay, now the way that we convert information from bit mode into from bit mode, which is how we're going to display the information from a bipolar prom. And a bipolar prom will only read and program in what we call bit mode. It will not work in byte mode. You will have to configure a file to work in bit mode before you program it. Or if you read a bipolar prom, it's going to read in bit mode, and you can save it either in bit mode or you can convert it to byte mode, and I'll show you how to do that. Okay, but if you look down here where it says enter editor command, all right, we have a special command in the editor for dealing with bipolar proms, and that is invoked with the # key, shifted 3. Okay, so I'm going to press the #. Watch down here. Okay, and it says bipolar prom byte/bit translation. Press plus to convert bytes to bits. Press minus to convert bits to bytes. Okay, enter option. All right, so at this point we have a screen of Fs. Okay, well, a screen of Fs would be the same as a completely blown bipolar prom. Okay, so if I convert this screen, and we haven't read a bipolar prom yet, but I'm just going to show you how this works. Okay, if I convert this screen to bit mode, all right, I'm going to press the plus key, all right, and you'll see that the screen changes to all 0 1s. Okay, a 0 1 is a blown fuse. A 0 0 is an intact fuse. Well, I don't have a prom installed in the adapter, so the adapter doesn't know there's no prom installed. So the screen just shows a whole bunch of 0 1s. All right, but if I convert it back, which is again shift # minus, it goes back to FF. Okay, now why is this important? It's really important because if you're dealing with a bipolar prom, and I'm going to put it in 82S129 in a minute, then when you read it, you're going to read it, it's going to show up in bit mode. Another thing that you need to understand, when you read a bipolar prom, a 4-bit bipolar prom, okay, the adapter will always read it as if it's an 8-bit part. Okay, what do I mean by that? I mean that let's say if it's an 8-bit part, you're going to have all zeros. Okay, if it's a 4-bit part, you're going to have 4 implemented fuses and 4 fuses that aren't there. Okay, because a 4-bit part only has 4 outputs, but when you look at the screen, you're going to have, where the fuses are intact, you're going to have zeros. in bit mode, and where the fuses are non-existent, you're going to have ones, okay? And in hex, a 0 is going to show up as a 0, and the 4 bits are going to show up, 4 unimplemented bits are going to show up as an F, okay? So in a 4-bit bipolar PROM, you're going to have to understand and remember that the data in bit mode for a 4-bit device, you got 4 fuses that are not there, and they are going to read as ones. Okay, so let me put a bipolar PROM into this adapter, and we'll read it, and I'll show you. Okay, now I've installed a 82S, it's not an 82S 129, it's an 82S 126, but they're the same configured, same kind of part, into the socket on the bipolar PROM adapter. The programming unit is on, and you'll notice, as with our the regular socket on the programming unit, devices are always inserted at left justified. All right, so let's go back to the computer, and I'm going to read this part into the buffer. The other thing that I want you to see is the device size is always going to be shown in bit values. Okay, so this is it's a 256 by 4 part. Okay, well, 256 bits, or 256 bytes, where each byte is 8 bits, is 2048 fuses. All right, and that's what this shows. Device size is 0 to 7 FF, which is 2048. Okay, if you multiply 256 by 8, you'll get 2048. So let's go ahead and read it. We're going to read it using command 3. I'm not going to go into the commands used with the programmer, other than the ones that are specific to bipolar PROMs. Okay, so we're going to go ahead and read the bipolar PROM into the buffer. And we're going to do that with command 3, read device in the buffer. And if you look down here, it says read at buffer start, address 0. So let's go ahead and read yes, no, yes. Okay. Now, here's the data from, this is a blank bipolar PROM, blank meaning all the fuses are intact. And what I want you to see is up here, okay? Each one of these bytes represents an individual bit, all right? So the first 4 locations, the first 4 fuses are intact. The next 4 fuses are not there. They're not in, they have not been physically implemented on the silicon of the bipolar PROM. It's just got 4 bits. So the next 4, as I said, this is 1 byte of data, but since it's a 4-bit part, these fuses are not implemented. Okay, so let's go, let me switch back to byte mode, and you'll see that we're going to have a whole bunch of F0s. All right, so let's go back to minus, okay, because the bipolar PROM, as I said, this 0 means 4 fuses intact. This F means no fuses blown. No fuses exist, or blown fuses. All right, so that is what you would see with a 4-bit bipolar PROM. All right, so let's go back to byte mode here, or bit mode. Shift plus. Okay, now what you can do, one of the problems, or that's not a problem, it's just an issue, is how do you know whether or not one of your parts is blank? Okay. With an 8-bit part, it's relatively easy because our software will do a what's called a device erasure test, and it will look to be sure that, you know, for a bipolar PROM, it will know that all of the intact fuses should be 0s in bit mode, and it'll say, you know, device, it'll say device is erased, which means the device is blank. All right, but with a 4-bit part, that doesn't work because it appears as though half of it is erased or blank and half of it is not. All right. So one way around that is to save a file where you have this pattern saved and just name it blank part or something like that. Okay. Now there's a way to do this, and I'll show you how to do it. One way is just to save a blank part to a file in bit mode, and then you're fine. Another way to do it is to, even if you don't have a blank part with which to work, you can flip back to bit mode or byte mode. Okay, and let's clear the buffer. And since it's a 256 byte part, you can use a command in the buffer editor called fill. You can say fill down here, fill buffer with constant, okay, 0 to FF, where FF is your last byte here in your 256 byte part, with F0. Okay, now when I press enter, you'll see all those F0s appear. All right, now at this point you could just do that and then switch to bit mode and change it. All right, but I'm going to show you how to save this. Let's first go to bit mode. Okay, so we're going to go to bit mode. Oops, shift bit mode. All right, and now we need to save this pattern from 0 to 7FF. And where are we going to save it? Well, let's see. Let's go to Command A. Find an appropriate place to save it. We're in the EPROM folder right now. We can tell that because it says current path is EPROM. So I tell you what, let's just go ahead and save it in EPROM. So let's create a file name. Let's call it what do we call it? 82S129 BLK or blank. Okay. Save defined buffer range. I pressed enter. Save defined buffer range. Yes. Okay. Now, if I go to the directory of EPROM, there's a whole bunch of files in there, but right down here at the end, you'll see 82S129BL. No, I didn't save the blank or the K because it's an 8-bit name. 82S129BL for blank. All right. Anyway, there's my blank file. So what I can do is, let's go back to the buffer editor. Clear this. I'm clearing by pressing the C key. Okay. Now, if I wanted, let's say I just got in some 82S129s and I wanted to know if they're blank. What I do is I go to my directory here where I've saved my file. You can make your own directory of bipolar parts and with our system, but I just happen to save this in the EPROM folder, and I can press F4. Okay, and now when I go back to the buffer editor, there is my erased or blank pattern for an 82S129. All right, now I can't just execute the erase command, and I'll show you why that doesn't work. Okay, here we have Command 6, verify device is erased. So if I do Command 6 and say yes, it'll say device not erased. See right there? So I've got to do something different. I've got this pattern in the buffer. So if I compare the blank pattern in the buffer with the part, if they both match, then I know my device is blank. So I can say Command 8, which is compare from buffer start, and I say yes, it'll say comparison complete, 0 errors. That's how you tell if a 4-bit bipolar prom is blank. Okay, just while I'm walking you through all this stuff, might as well see all the tips and tricks that you can do. Okay, now let's go ahead and program this bipolar prom. We have some files which are 4-bit files that we have been requested to program. and they are installed on a flash drive. And I'll show you, we've already got the flash drive installed on this computer. So I'm going to navigate there. I'm going to press F5. We're going to scan 4 drives, and we got this is on drive E. Okay, and we have 82S126. Okay, there's the directory of those files. So let's just check out what files are there. So from there, I can just press F2 to view the files. And HBPROM.2E is one that we have been requested to program. So let's go ahead and program that. And to read it into the buffer, we'll do that. So let's just press F4. That will read the file into the buffer. Now watch what happens. Okay. This file is not in bit mode. This file is in byte mode. Okay, so when I go to the buffer editor, I see a whole bunch of zeros where there are actually no bits. Okay, so what we need to do is we need to change all of those zeros to ones, and meaning that in the first location here where it says 0F, that should be an FF. Over here where it says 0A, that should be an FA. Well, it would be kind of tedious to go through and literally byte by byte change it. So we have a command in the buffer editor, another thing that's kind of unique about our product, called logical operations. And logical operations will let you do what's called an AND or an or an exclusive OR on the data in the buffer. So how does logical operations work? Well, if you want to know exactly, you can use the help key, all right? And these are all the summary of the commands in the buffer editor. Logical operations, XXX, YYY, start address, end address, and then the data, meaning what you want to, or what logical function you want to use, and then you tell it what you want to do. Okay, whether or not you want it to be an AND, an OR, or an exclusive OR, which would be an invert. All right, so let's go back, and we want to make all of the upper nibbles ones. All right, so we're going to do logical operations, and then we're going to say 0. 2. Now remember, we're in byte mode. Okay, the device size is in bits, but this screen is in bytes. So we're going to do 0 to FF, and we're going to OR it with F0. Okay, because the F will change the 0 to all ones, and the 0, when ORed with whatever the data is there, we'll leave it unchanged. So we're going to 0 to FF to F0, and then we press enter, okay, and it says enter operator, A for AND, O for OR, X for exclusive OR, so we're going to say O for OR, and now all of the upper nibbles, if you see, the FF, F0s, or 0Fs are now FFs, 0A is now AA, so this is now ready to be programmed into the part, but we have to convert it back to bit mode in order for that to work. Okay, so how do we do that? Shift, #, plus, and we're now in bit mode. Okay, so you can see all the zeros and ones. Remember, it was F0 before. Now we have 1, 1, 1, 1. So it's all F. So the unimplemented bits in the bipolar PROM are going to read correctly after programming. Okay, basically it's going to try and program non-existent bits, but since they're not there, nothing's going to happen. Okay, so how are we going to proceed? We're going to program the bipolar PROM from the buffer. We're going to use the program command to do this because I forgot that the program device from buffer command does not allow you to do an override. So let's do a program. P, program device from buffer, starting address 0, press enter, enter ending address 7FF, enter, programmer skip, program, device not erased, new device installed, no. Okay, now look here, it says override, all right, and this is what you're going to do because this is a 4-bit part. It thinks it's not erased, but you're given the option to program it anyway. So let's say yes, and it'll go ahead and program the part, and it says program complete, data verification is correct. Okay, so we have now programmed this part, or the file, into this part. I know, it seems, it's a bit tedious, I admit it. But when you're dealing with bipolar proms, and if you don't have a programmer from the 1980s, this works. The only thing that you have to deal with is if you're dealing with a bipolar prom, you have to compensate for the fact that 4 of the bits are unimplemented. Okay. Now, if we clear the buffer, program another set. No, we're not programming anymore. Clear the buffer, and then let's read this part into the buffer. Okay, so we're going to use command 3 and read it. Yes. Okay, now there's the data. Now let's convert it back into byte mode so you can see it. Oop. Unsigned. Okay, and there's our original file after we modified it. Okay. Remember, we went in and we converted all of these 0Fs to FFs. And the whole reason to do that is the upper nibble doesn't exist in the bipolar prom. Okay? So we've now programmed a 4-bit bipolar prom, and it verified correctly. If you want to go back, let's convert this back to bit mode. Okay? And now let's compare it, which is command 8. 8. Yes. Okay. Comparison complete. 0 errors. So we know that the data from the file, which was converted to be compatible with a 4-bit part, was programmed successfully into the 4-bit bipolar prom. All right. That's how a 4-bit part works. Now, let's do an 8-bit part. Okay, if you look, I have removed the 82S 126, 82S 129, 74S 287 configuration block and replaced it with the 74S 188, 82S 123, which is the one where the jumpers just go straight across. So let's switch back to the computer display and get rid of the data from the the 82S 129. So now, when we read, let's see, we need to change the device type. So we'll go to command 9 and enter, let's do the 74S 188. Okay. So now, it says requires bipolar prom adapter. Yes, we knew that. And we are now ready to program a 74S 188. The 74S 188 is 32 bytes by 8 bits. Okay, now what is that? All right, well, here is the buffer editor. 32 bytes is from here, byte 0, to here. Okay, so that's it. This is your, in hexadecimal display mode, you got basically 2 lines of 16 characters. Okay, but if I convert that to bit mode, it's going to be this size, FF. All right, so it's going to be the entire screen of 0s and 1s. Okay, I've just inserted the bipolar prom into the socket on the bipolar prom adapter. Now I'm going to switch back to the computer screen, and here is the buffer is initialized to FF, but let's read the blank bipolar prom, blank 74S 188, into the buffer. So I'll use 3, which is read device of buffer start, say yes, and all fuses are intact. Okay, so I got all 0s. Now, let's go back to the main command list, and I'll show you this. Okay, command 6, which is right here, verify device is erased. The erase command will work on an 8-bit part because the system knows that 8 bits in a bipolar prom are 0s, not 1s. So if we say verify device is erased, which is command 6, press 6, device on socket, yes, it'll say device is erased. Okay? So we know that our part is blank. Now let's program it. I'm going to sacrifice a blank 74S188 for my demonstration here. So let's go back to the buffer editor. Let's clear it. I'll just clear it. I clear things, use the C key, which is to clear. And now I'm going to say, I'm going to enter our business name. Okay, modify, address 0, enter. And down here, I want to do this in ASCII since I'm going to be typing our business name. Enter in hex, tab to change. So I press tab, we change it to ASCII. And now we can type ANDROMEDA. We'll just put in spaces here. Research, RESEARCH, space, labs, LABS, put in some exclamation points. And we are now ready to program Andromeda Research Labs into our bipolar prom. But what do we got to do first? Okay, you can't program this until it's in bit mode. So we're going to change this to bit mode, shift, #, plus. Okay, this is what Andromeda Research Labs looks like in bit mode. Okay, all the zeros and ones sprinkled around in there. So now for an 8-bit part, because it's going to test for erasure, I don't have to use the program command. I can just use program device from buffer start. So I use command 2 to do this, although I could use the P, the program command, which I did for the 4-bit part. Because it lets you do the override, but 2 will not test for, it will test for erasure, and the system will indicate that it's erased, so it will allow me to go ahead and program. So press command 2, program from buffer start, yes. Okay, programming complete, data verification, data verify correct. So we have now programmed Andromeda Research Labs, exclamation point, exclamation point, exclamation point, into the bipolar prom. All right, and it worked. Programming complete. So that's how you program bipolar proms. Now let's go ahead and let's clear the buffer, read the data from the part 3. Yes, there's all my zeros and ones. Let's convert this back into byte mode. Shift minus, and there it is, right from the buffer. Now, if you're backing up bipolar proms, all right. You can choose how you want to save. All right, you can save the buffer either in byte mode or in bit mode. But you have to remember, if you save it in byte mode, you got to convert it to bit. If you save it in bit mode, then you can go directly and read and program. Okay, but it's got to be in bit mode in order to do that. But we'll let you save it either way, because the save function, if you're going to save in byte mode, this is only 32 bytes, okay? So, since I've gotten you this far, let's do this. Let's go to the path command. Let's get out of the flash drive. Oops, path command, F5, scan for drive. We're going to do this in drive C. We're going to go and we're going to do something kind of different here. Press F10. Now you'll notice down here we have just set our current path to drive C. So now I can press Alt-A, and it'll say add new directory to current path. Enter name, okay. Let's call this Bipolars. B-I-P-O-L-A-R-S. Okay, that's going to be the name. 1, 2, make sure I don't have too many characters here. 4, 5, 6, 7, 8. Okay, Bipolars. And it says, add new directory now. Yes. Now watch what happens. Boop. Okay, here we are. Bipolars. Now, I'm going to move over to Bipolars. And if I say down here, it'll say view files. So I say view files, F2, no files. So we haven't saved anything yet. All right, but we are now pointing at, all right, let's go back to path. Where are we pointing? We are pointing at Bipolars, okay? because this is how you do it. You move around. If you want to go change to another directory, you can press enter, you can press insert, or you can just press F5 to view files, and it will automatically choose that path for you. But anyway, so we are in bipolars. And now, here's another trick. While I'm showing you tricks, press F2, no files. But down here, it says enter file name to recall. Okay, well, let's just give this a name we'd like to use in the future. Let's call it 74S188. I'm going to call this one .dat for data. All right, and I'm going to press enter, and it appears as though nothing happened. But what happened was that file name was saved. Okay, so now if I go to the buffer editor, well, first of all, look here. Okay, Command A is save buffer to disk file. And also, if I go to Command 5, there's my file, which I'm going to convert that to bit right now before I forget. Okay, Shift plus. Okay, there's my bit mode. I want to save this in bit mode. If I press A in the buffer editor, I also have save buffer to disk file. Notice that my current path is now C:/bipolars. And if I give it, it says enter file name, or over here it says press insert to recall file name. Well, if you remember, I gave it a recall file name. So all I have to do is press insert, and there is my file name, okay? And when I say enter, it'll say save defined buffer range, defined range 0 to FF, which is all of the fuses. Save, yes, file save complete, okay? So that is how you do it. And I just showed you an extra trick there at the end. Since if you've spent as much time watching this as I have spent making it, I applaud you. Okay, but the whole point of this is to help people who are dealing with vintage equipment that have the requirement to program, read and program backup bipolar proms. The EPROM Plus system with the bipolar prom adapter will do it. Okay, so I also wanted to show you the 4-bit versus the 8-bit, and I also gave you a bit of the history and why bipolar proms are used. So I suppose that is that. So if you found this information useful and interesting, and you like the content of how things from the past work, you could give us a like. If you want, you can subscribe, and as we introduce other videos, and there are lots of things on which we can do videos. Honestly, right now, because of the market, our product is very popular in the automotive repair market right now, and this is August 1st, 2024. But we had the opportunity to do this. Hope you found it useful. And in the future, if you want to understand more about our products and see what we have, or if you would like to contact us, we actually have people that answer the phone and can provide you with information. You can send us an email. All of that information is on our website, which is arlabs.com.